Welcome back to this ABAP object-oriented video series. This is part 2. We're going to look at the difference between instance and static, two very important concepts in any object-oriented implementation. Now let's start with the simpler of the two, which is static. And the concept of static, and you can say that a class is static if all of its members are static. We can apply static to the concept of methods or even data. And really, it's difficult to explain static without understanding what instance is. They're the opposite of one another. But we're going to start with static because, as I said, it's the simpler of the two. It's more like creating old-style function modules or forms, because the class itself really just becomes a holder for code and not really much in the way of data. As we'll see, I think it's clear when we contrast the two, but let's start with static. And what we want to do is we created a class, just a normal class, nothing special about the definition of the class, and it has two methods, one that will retrieve the flight details by key, and one that will calculate the flight price using those details, and will give us the price and the currency code for a particular flight. Now, what you're going to see here, instead of declaring just a regular method, we've added the modifier onto the front called class-method. That's what makes this a static method. And as you'll see here, there's no data persisted between the two method calls. Okay, so unlike what we'll see with instance in a minute, where you create an instance of the class and it's like taking different copies of the class and the code that goes along with it, along with data. This is like having one class. There's no copies of it, there's no instances of it, it's just one copy of it, and we can directly call the code and have it executed and get a return value back. But in our situation, you see here, we get the flight details. That's going to allow us to go to the database and look up the details based upon the keys: carrier ID, connection ID, flight date, the three keys for the flight table. But then when we calculate the price, we can't carry anything over from the flight details. We have to once again pass in all three key fields. So, this is good for creating isolated blocks of code that really have little or no connectivity to one another. There's no data flow between these two methods. It really just becomes a way of grouping code together, but as I said, there's no way to flow data between one method to another in this case. So it's becomes the most simplistic form. And honestly, should probably avoid class methods for the most part. This isn't really a great pattern to follow. Instances, we'll see, it takes a better advantage of the power of object-oriented. But if you're porting over from function modules, this is often a natural way to do things. Later, we'll see there are some special use cases where you might use class methods, static methods, to instantiate the class itself off of a base object or some sort of abstract object, but that's a much more advanced object-oriented concept, and we won't get to that till the very last of our video series. So instead, let's just go ahead and look at how we execute this class, and because it's static, we're just going to test it from within itself. It won't give us any weird side effects or anything. But we're just going to say, we're going to call the calculate flight price. And notice we're not getting anything back. There's no object instance being created, because obviously this is an instance class. We're not having to say new class or anything like that. We're just able to call the method and pass in those keys, right? And we're going to get data back and we're going to output it to the console. And then the same thing, you know, with the flight details, and there's really no connectivity between the two. Um, but as we'll see here, we have to repeat the database access here. So in the calculate flight details, we have to go select from the flight table, even though maybe we've already read the flight details, or vice versa, where we've done a select single here from flight, and here we've done a select of just those certain fields that we need. But we've got redundant database access going on here that really wouldn't be necessary. Wouldn't it be better if whichever method gets called first, we could keep that data in memory as part of the class and keep us from having to go back to the database a second time for another related method? So that's really the downside to this approach, is there's no connective tissue between the two, and leads to a lot of redundant, as I said, redundant database access. So not terribly impressive here. It's F9, and we'll see it output to the console. Go ahead and say run as console. There we are. And we see our flight price was output, and our flight price for UAA was output as well. But in this case, we actually passed in some bad data, and we still see a value being passed back out, because we're in our calculate flight price, we are adding a surcharge to the price, but it actually didn't find a record in the database that matched. But we didn't have any logic to check that, because our focus in the calculate flight price was on doing the calculation of the price, not retrieving the data, checking to see if the record really existed. So there's a lot of things lacking here in this approach, between the redundant database access, the really kind of bad because we're not checking return codes, we're not checking to see if we actually found a record in the database, and then we go ahead and return a price that's kind of bogus. We didn't really tell the caller that, hey, there's no valid data here for that. That's not a valid flight. So we're lacking in several ways. Now let's have a look at using an instance methods, and this is the much more common way to use classes in ABAP, or really in most any environment. So we'll take the same class, and I'll just show you here, essentially doing the same thing. We still want to read the data from flight table based upon our 3 keys, and we want to calculate a flight price by taking the price from the database and adding a certain upcharge based upon which plane type it is. But we're pretty drastically different. It's more than just removing the, changing class methods to class. Changing class methods to methods. We've got a whole new thing here called a constructor. Okay, a constructor is a special method that is called automatically when you create a new instance of this class. And this allows us to pass our keys not into a particular method, but when we first want to access this class. And in a way, we take a copy of the class and its logic as well as its data for those valid keys. And this is the real power of object-oriented concepts. We take data and logic and we group them together, not just, as we've seen, logically inside of a class, but inside the instances of those classes, so that I can create an instance of the class for, American Airlines flight number 0018, and I can create another instance of the class for United Airlines flight 2920 or something, And both of those can live in memory, and I can call the methods of the particular instance, and I don't have to pass the data, the keys back in when I call those methods like we did in the previous example. The data becomes part of the instance of the class as well. So what we see here is we're gonna declare some data, an internal table, basically here of type flight. Actually, a structure in this case because we're only returning one record. So just a structure of type flight. We're going to pass our keys not into each method, but into the constructor. And inside this constructor, that's where we're going to do our select from the database. So we're not doing the redundant selects. Now, we still haven't added any validation logic, exception handling. That'll come a little bit later, but you can already see that we're better set up to catch exceptions, to catch when we get bad values passed in. We could actually abort the creation of the instance if it was bad, and we'll see that a little bit later. So just put that aside. We'll get to that. But assuming we get good data back, we can now calculate the price, and when we call the calculate flight price, we're not going to go back to the database. We can use me to access data that is part of the instance of the class. So this flight, the structure, so me, it references to myself, this instance of the class from inside the process of the class, and then flight is a structure, and then price is just a variable in that structure. And the same thing with currency code. The same way that we fill this in the constructor, select into flight, right? And we take the input parameters. And the same thing on returning the flight details. We don't need to go back to the database. We can take the internal structure and give it to the returning parameter of get flight details. And it's going to pass the data out, all right? And what we'll see here is now we've put this in a separate tester, and we did that for a reason. Oh, I messed up I didn't want to do that. What I want to do here is pull them side by side so we can see this a little better. Because as we'll see in the next video, we haven't talked about visibility, public and private and things like that. It's going to have a pretty big impact. And now we want to test from outside of our class so that we can test visibility as well. But like I said, we'll get to that in the next video also. But for now, what we want is we want a little tester class. And you see, unlike before where we just directly called the method, now we create a new instance of our class. So we say new, we tell it what type of object we want to create new, in this case our class name itself, and then that immediately calls the constructor without us having to say call method or chain it in or anything like that. The constructor is called. You see the 3 importing parameters of the constructor, and then we have a data object. It used to be we would declare this data object type ref2, the class name type, but the ABAP language has evolved. It's a bit more elegant now, and we can have those data declarations take on their type automatically, and that's what we're doing here. We're saying data, and we put our variable in parentheses, and we don't have to pre-declare it. It's going to take on the type automatically, and it's going to be a type ref2, our ZCL 00 tutorial 3. But now we can call the methods of that particular instance of the class, and all the data that's stored in it, this data flight that we prepared in the constructor, is going to go along with that instance, that version of the class. That's only going to live for a few seconds in memory and be thrown away, be flushed away. It's not something persisted on disk or in the database or anything like that, but it allows us easy access and reuse of the query that we've already done. So, for instance, here we just call the calculate flight price. I don't pass anything in. It's by the virtue of the instance that I have access to that we're even able to re-access that original data. We're able to, output the results, and we can get the flight details, just as we did before, but once again, not having to pass anything into it, right? And if I were to now test this. For whatever reason, my F9 key is not working, so we'll come here and we'll use the run as again to the ABAP console, and we see the same output. You really wouldn't know any different from what happened here. We still aren't dealing with exceptions, as I said, so we have the same data output, but we have less redundant access to the database. I would say cleaner code. You know, and what's interesting here is, let's look at this in the debugger as well. Let's go ahead and clear this. Let's just set a breakpoint here after the last one has ran, and let's go ahead and run this again. And we'll switch to our debugger view. Yes, please switch for me. And what we see here is we've stopped at this write statement. But really what I want to show you here is these two locals that are declared. We see AA0017, that's our first class instance, and UA0017, our second class instance, the one that's not really any good. But you can see right here the types. They're both type. The actual type is ZCL00 tutorial 3, type ref2. And inside the debugger, we can expand these, and we can actually even see the data that's being stored there. Now, this was a very simple example, just one little piece of data inside the instance of our class. You can imagine normally classes are much more complex than this, many methods, many pieces of data internally. It becomes a much more organized way of grouping your logic and your code, and still being able to get easy access to it from the outside, as you see here. Let me go ahead and continue my processing. We'll get out of the debugger, back to our standard view, and I'll remove that breakpoint. The last thing I want to tell you about in this discussion of static versus instance is this whole concept is really powerful. We created individual instances, but it's possible to even put an instance of a class in an internal table and create a whole array of instances and manage them as we would any other data object in ABAP. So let's have a look at that here. And this is looking ahead just a little bit, but I want to go ahead and tease you with this. Is maybe a few other concepts that we haven't talked about yet. But what I'm going to do here is I'm going to select my keys into an internal table, and then I'm going to loop over that internal table. And for each record in that internal table, I've got a place to hold an instance of my class. And I can do the same thing. I can call the constructor within that loop, and then the instances of that class are going to be in that internal table. Now, let's not go into all the rest of the logic that we have here. Like I said, this is a little bit later example, but I just want to show you this one thing. Put just a little dummy logic here at the end, just so we can have a nice place to set a breakpoint, so I can show you this. Let's go ahead and say run as. Once again, we'll. All right, I figured out what I did wrong here. This has to do with exceptions and how we're never getting to this block of code because I'm using a later example that has some exception logic in it that we haven't talked about, so I don't mean to confuse anybody there. But what I do want to show you here, real quickly, again, I've set my breakpoint now inside my exception handler, so we'll be able to see this. I just want to show you what this looks like inside the debugger when we have this internal table of object references, or instances, if you will. So let's switch into the debugger perspective. And at this point, so we have our table flights. If we expand our internal table flights, we see that we have 41 records. If we look at the first 10 records and drill into each record, we see each one, in addition to having the keys, a regular structure here, we have this flight object. And inside flight object, each one of these is a type ref to our tutorial class, and we'll see it here in the second one as well. The third one, you go down the line, you'd see them all in there. And inside each instance, we've got, just like we had before, we got the individual data, methods, and everything that goes along with it. So, don't think that this is limited to just one or two instances. We can create large groups of instances, just as we would with any other types of data, using internal tables and all the powerful processing that we have on top of it, just in a much more organized manner. And as I said, once again, keeping the logic, the methods, the execution, along with the organization of the data via multiple instances. So a truly powerful concept of object-oriented, and what really sets it apart from traditional regular ABAP programming, either function modules or programs alone.